Greetings everyone! In this lesson, we take a shot at creating blueprints, a visual scripting tool to add functionality to your project. This can be used for gameplay, but also as a tool to make our life easier. We will first learn how to take advantage of that when creating our own actors, and we will then move on to some interactions. Finally, we'll conclude with an example used for player movements, so let's jump right in. Our first example will help us to make changes across multiple actors at the same time. This will be really useful when dealing with a lot of repeating objects. To create our first blueprint actor, right-click and select Blueprint class. Here we will select a parent class which our actor will inherit some functionality. Some examples could be the ability to walk, drive around on wheels, or possess any actors. We will stick with the basics and we'll select Actor. Now I intend to create a torch that will be placed all around the level. Controls that I want to have are the ability to change the torch model for any actor while having a global control for light color and intensity. Give a suitable name for your blueprint and open it. You should now see a node graph or a viewport. In the case you are seeing none of that, top right corner and open Full Blueprint Editor. In here, I will start to add components to our actor. These will be the building blocks for our torch. The first step is to add a static mesh component to add the torch model. Top left, reach the components panel and add a component. There's many types of components to use. Use the search bar to find the static mesh. You can rename it however you like, in my case, torch model. A details panel at the right is available to change some properties you might already be familiar with. In the static mesh category, select your model. If you found yourself in a node graph, switch to the 3D viewport to see our torch model placed in its very own world. Also give it a material and make sure to set the appropriate mobility. In my case, this torch is meant to be static. The center of this world will also be the pivot point for the torch, so be wise about it. Next component we will add is a particle system to add fire. In the details panel, I will set the template to a fire particle system. And now hit compile to apply all our changes and save. Let's test our actor to see the result. Place the torch blueprint in your scene and make as much copies as you want. Not too bad, but even though there's fire here, no light is emitting. Typically, we would have to manually place a light over all the torches, but luckily our blueprint will take care of that. Go back to edit the torch actor, and this time we will add a light component. I'll choose point light, and I will place it just above the fire. This light should cast shadow on a character, so I will set its mobility to stationary for dynamic shadows. I'll set a nice fire color using the temperature. And going back in our scene, all our torches are now updated with the light. This is all well and good, but now we need controls for individual torches. Edit the blueprint, and we will now change view from viewport to construction script. This is a node graph of code that will be running while working in our level and not during gameplay. This will be used to change components' properties on individual actors. To change the torch model on some actors, I'll drag my static mesh component in the graph to begin working. Drag the pin out and let go to reveal a search box. In here you can find many functions and events. We'll search for a function called setStaticMesh. Now the construction script node is responsible to execute the graph. Pins displayed as arrows controls the execution. Drag the pin into the execution input of the setStaticMesh. On the setStaticMesh function, grab the new mesh input pin. This time select Promote to Variable. This variable will hold the torch model when changed in the scene. Your variables are listed in the variable category on the left. Change the name accordingly. An eye icon next to the variable name will make this variable public so it can be changed at runtime, which is exactly what we want. Compile, and in the Details panel, change the default model to your torch. Now going back in our scene, select a torch of your choice, and now in the Details panel, a new property has been added to change the model. So far so good, but let's take care of our light and add some parameters. Back in the construction script, drag your light component in the graph and drag out the pin. Now we'll call a setIntensity function. Get the execution from the setStaticMesh to the setIntensity. Now we need a variable here to contain the new intensity value. Drag new intensity value out and again promote to variable. I'll name this one light intensity. I will enable the eye icon to make public. Notice the type of variable. A green tag means a float value, just like a scalar parameter used in materials. A blue house, used for the torch model, holds a static mesh. There is a lot of variable types, but don't worry, we'll stick with the basics. Remember to set a default value for your light intensity. Now for the light color. Drag out another wire from the light component and call setLightColor. Now promote the new light color to a variable and make it public. Now this one has a blue tag, meaning this type of variable is holding a linear color. Change its default value to something fiery, compile, and save. Going back to our scene, we can now change light intensity and color on some of our torches, and without affecting everything else. Now that we have a basic understanding of how to work faster with blueprints, let's add a bit of interactions. Edit your blueprints and switch view to event graph. This node graph is different than the construction script because here, the code will only run when the game is played, which makes this graph perfect to script events. In this simple example, I intend to switch off torches when I'm close enough and I'm pressing the E key. Let's get to work. The first aspect I'm going to take care of is the player detection when it's nearby. We'll add a component, a simple box volume, to detect player overlapping. In the 3D view, place the box large enough so the player can easily reach in. Switch back to the event graph. There's some node already available here, but since they are not connected, they won't be taken into consideration. With the box component selected, reach the Details panel and go down in the Events category to select on Component Begin Overlap. This red node is an event that tells the engine to send an execution signal as soon as the player enters the volume. We can test our work with a neat little function called a print string. This will return a string of character, making this super useful for testing and debugging. Get in play mode, and now if you approach a torch, the print will return hello. Now that we know this is working, we will add another event to our box component to fire an execution as soon as the player exits the box. Add another print with text so you can test your work. Next step is to set a button for the player interaction. Go to File, Project Settings, and reach the Input category. In Bindings, add an action mapping called Interact. Choose any key you want and we're done. We can now right-click to search for that Interact event we just created. Now on pressed, we will add a print saying button pressed to test this out. Before doing so, however, make sure to go into class defaults at the top and go down the Details panel, and in Input, change Auto Receive Input to Player 0. This is telling our torch blueprint to listen to keys being pressed. Now in play mode, if you hit your key, the print will be displayed. We are making great progress. Now we need a condition here to tell the torch to switch off only if the player presses the key and is inside the box. First, we need to create a new variable. we need a special type called Boolean that simply returns true or false. We won't make this variable public. I want to set this variable to true when the player overlaps the box. So to set it, hold on the Alt key and drag your Boolean in the graph. We will place this just after the begin overlap event, and we will set the variable to true when the execution goes through it. Following the same logic, duplicate your set and place it after the end overlap and uncheck the Boolean to set it to false when the player moves out of the box. The print can be used to display any type of values. With the set Boolean output, plug it into the string of your print to display the value of the Boolean. We can now get rid of those prints as we know our logic is working properly. Now we need to check if the Boolean is true or false when we interact. Drag out the pressed to search for a new node called branch. This acts as a condition that will split the flow of execution based on the Boolean value. Speaking of Booleans, we will grab our variable from the list, but now we will hold on to the Control key to get the value. Plug the output in the input condition. Again, I'm testing using prints to make sure everything is working. We now have a working logic, but we only print strings and we actually want the light to turn off. Drag your light component in the graph and drag out the pin to search for set visibility. Make sure you have context sensitive activated so Unreal proposes function compatible with your selection. We can also turn off the particle system using the same technique, but now using the deactivate function. Before testing, select your interact event and disable consume input so every torches are listening to the player interaction. Now in play mode, we can get close to a torch, and when interacting, the torch goes out. This completes the interaction example, and we will now conclude with our last blueprint example, which is used to control a first-person character that can look and walk around. Create another blueprint class, and as a parent class, we will choose character to inherit movement abilities. Rename your character blueprint and open it. We have new components by default using the character class. We now have a capsule that will collide with objects in the world, an arrow indicating the front of our character, and a mesh to add a character model. Below this component, we have character movement, which are abilities already available to work with. You can tweak parameters for walking speed, run, swimming, jumping height, and a lot more. We can switch to even graph, but before placing in some nodes, let's define our bindings for the player. Return to project settings to set bindings, and we will add here a few more inputs. We will use a WASD layout to control our character. Using axis mapping, the first thing we'll add will make the player move forward. Add 2 keys to go forward and backward, and change scale to -1 for the S key. Moving on to another axis that will be used to walk left to right. Add 2 keys again and set the scale value to 1 for D and -1 for A. The character can now move, but we still need to set inputs to look around. Add another mapping to look left to right. This time, we will use the x-axis of our mouse to rotate our head around. Set the scale to 1. The final mapping is used to look up or down, so this time use the mouse y-axis with a -1. We're done with bindings, so let's get back to our event graph. You can safely delete the default nodes as we won't be using them. Search the axis event by typing its name in the search bar, and drag the execution pin, and here, search for add movement input. Plug the axis value of your event to the scale value of your movement input, and we now need to define which direction the character should walk. Search for a function called control rotation under pawn. Drag out the return value and get forward vector. Return value goes into the world direction and moving forward is now possible. Now to walk sideways, Get your axis event in the graph, and again, use add movement input with the scale value properly connected. For direction here, get back to control rotation, drag out, and get right vector into world direction. We'll test our movements in our scene, but before we need to create another blueprint that will select our character as the default player. In the content browser, create a new blueprint and select Gamemode base as the parent class. This class is used to define the rules of the game, how many players can play at any time, and keep track of score, for example. In the class default, we will change default pawn class to our character. Now to use this game mode for our project, select Blueprint, Game Mode under Project Settings, and select your Game Mode class just created. Hit play, and we can now move around, but we still can't turn our head. Edit your character blueprint and search for axis event to look on our sides. Drag the execution, add controller yaw input, and plug the axis value of our mouse in the value of our function. Do the same, but for the other axes. This time, add a controller pitch input, and make the same connections as above. We can group our nodes using the C key to add comments and keep our graph organized. Now in play mode, I can walk and look around freely, be blocked by wall, and still can interact with some torches. So this wraps it up for this lesson. With this knowledge in mind, you can start to create your own actors to speed up your workflow or add basic interaction to make your project even more enjoyable. So until next time, take care and have fun with it.